are the roots of sin square x plus a sin x plus b equal to 0 and cos square x plus c cos x plus d equal to 0. If cos of alpha plus beta is equal to a naught a square a1 b square plus a2 c square plus a3 d square divided by b naught a square b1 a square b2 c square b3 d square, then what is the value of minus a naught plus a1 plus a2 plus a3 the whole divided by b naught plus b1 plus b2 plus b3. See, believe me, like when such a question appears in advance, 99% of people leave this question. The reason for that is the number of variables being utilized in this. Like alpha and beta be the roots of some two quadratic like expressions, and which again contains a, b, c, d and variable with x. With that itself, you can literally reach the what do you say, 7 variables. And then in question extends, right, cos of alpha plus beta equal to a naught a square, a1 b square, a2 c square by plus a3 d square. Similarly, in something denominator. That brings in some 8 more variables. A naught, a1, a2, a3, b naught, b1, b2, b3. Okay, so literally 15 variables. Who could solve such a question in exam time? Is it possible? Right? So it's not. So that means the question was framed on a simple thought. Just for you to get frightened or like not comfortable, they might have written it like this. So tell me, just think about this alone, people. Cos of alpha plus beta, like, okay, some cos theta formula, like read it that way. Some cos theta formula written as a fraction. Which formula do you recall like that?
Cos 2 theta?
Exactly. Cos 2 theta, you have so many variations. Cos square minus sin square, 2 cos square minus 1, 1 minus 2 sin square, and 1 minus tan square by 1 plus tan square. In which of these formats it was like looking like a fraction?
1 minus tan square by 1.
Absolutely. Then the question should have been made only on that. So it should be, we can start with the thought of 1 minus tan square theta by 1 plus tan square theta. Agreed?
Yes, sir.
Let's go back to the question. So alpha and beta are the roots of these quadratics. Okay. So alpha and beta be the roots of this quadratic, meaning the values of x actually. Yeah. So that means sum of zeros when I do, and you do SOZ for the first equation, won't it look like sin alpha plus sin beta? Because they are the two roots, which will be equal to minus b by a. You'll get this, right? Sum of zeros of the second equation, cos alpha plus cos beta, will get us minus c by 1. Am I right?
Yes, sir.
Now think about it.
So
I
I
need to
don't
get the
understand why is it sin alpha plus sin beta?
alpha and beta are the roots of the equation, meaning like it's the values of like x. So you can see this is a quadratic in sin x, no?
Right, sir. Thank you.
Means the values that sin x, sin x form as such like sin alpha value or sin beta value, or same as cos alpha value or cos beta value.
Right, sir. Thank you.
Okay, since you see the question, it's an half angle form, so you can do like the addition formula, because this is like sin of a plus b plus sin of a minus b getting added up, which is nothing but 2 times sin a cos b. Correct? Same thing denominator, 2 times cos a cos b.
Can we also say sin alpha sin beta is equal to b, and cos alpha cos beta is equal to c,
Yeah,
and then we can
the
expand.
product of zeros, yes. Okay, so when you divide these two expressions, you will get like 2 getting cancelled off and a by c on the right hand side. So you'll get tan of alpha plus beta by 2 value as a by c. Okay. So when I substitute that here, 1 minus a by c the whole square by 1 plus a by c the whole square. Am I right?
Yes.
So this is what you're getting, people. So now you can just exactly compare this to the question format. So then a naught a square. So what is the value of a naught?
-1.
-1.
And b term is not there in the numerator. So a1 is 0. C square is there. So coefficient is 1. A3 0. Understood?
Yes, sir.
Similarly, in the denominator, b naught is going to be 1. b1 a square. Sorry, b naught a square. No, I made a mistake here. Sorry, b1 b square. So b square not there. b2 value b2 c square. So that's 1. And b3 d square, that's not there, 0. So you have all the values of the variables. You can just substitute in this final form to get your answer. Your answer is going to be
1, sir. 1.
yes, absolutely.
Sir, can we not do in this way, sir? Cos of alpha plus beta, we expand it, sir. Sin alpha, sin beta plus cos alpha, cos beta. And product of roots is this we are getting, sir. Like
Mm-hmm.
sin alpha, sin beta will be equal